everyone, welcome back to our math class. Today in this video we are going to discuss quadratic function, and the focus of the lesson will be talking about the graph of the function. So let's have a quick check how the graph of quadratic function looks like. As you can see this picture, if we connect the trace of the basketball, it will form a curve. And we do have a name for this curve, which is called parabola. So parabola is the name of this shape of the quadratic function, and also just let you know, this is also represent a very useful application of quadratic function, which can be used to model real life situations such as the movement of throwing object, such as when you throw the object in the air from the top of the building. All those kind of things can be modeled by using quadratic function. So today, in this video, we are going to discuss how we analyze the key features of the graph for quadratic function. Let's have a look. So in this video, we are going to look at the graph on the left for this one, and we are going to use this graph to analyze terms such as vertex, axis symmetry, all those kind of words. Let's go one by one. First, vertex. Vertex is actually the highest or the lowest point. It's like located in the center of the graph. So if you check this, it's actually this one. So this is the vertex. And based on the location here, we can just easily read the coordinates, which is -1, 4. Because when you read it, x is -1, y is 4. So the vertex for this one is the highest point. Of course, sometimes we have a curve like this. If the parabola open like this, then this can also be considered as vertex, which is in this case the lowest point. For axis symmetry, which is if you check the word symmetry, meaning if I fold the graph through a line, it will match into each other. So if we check the vertical line passing through the vertex, as you can see, if we can fold the graph according to this right line here, this is actually the graph can match into each other, then this is called axis symmetry. And since it's a vertical line and passing through the x-axis at -1, so the equation is x equal -1. Be careful, sometimes it's easy to make mistakes, such as I write down -1, or I write down just y equal -1. All these kind of answers are incorrect because it's a vertical line, so that's why we write this as x equal -1. For x-intercepts, which is the points where the graph touch the x-axis. As you can see, these 2 points are the x-intercept, and if we write down the coordinates, will be -3, 0, and 1, 0. And the common part between these 2 parts, you notice that the y is 0, so that's why instead of calling x-intercept, we can also call this 0 function. And if we are talking about 0 function, we can just write down this x equal -3 and 1, because these are the 2 values make the y as 0. And since it's related to the equation, we can also call them roots of the equation or solution of the equation. They are all the same thing, solution to the equation. Okay, so the y-intercept in this case is where the graph touch the y-axis, which is at y equals 3. You can also write down 0, 3. This is the location for the one. And if you check the mouth of the graph here is open downward. And just because it's open downward, so that's why we're looking at the highest point in this another case, which is the maximum value. And when we talk about value, we actually talk about the y value. In this case, if we match into this, is y equal 4. And also you can link to the vertex here, the y coordinate of the vertex, which is the maximum value of the graph for this case. Okay, next we are going to discuss the increasing interval, decreasing interval. First of all, when we talk about the increasing, decreasing, we look at the graph from the left to right. And when the graph is increasing from the lower side to the upper side, this is increasing. And if this is from the higher side to the lower side, then this is decreasing. For the interval, it's actually talking about the x values that when the graph is increasing, then that part of the value is increasing interval. Accordingly, if we're talking about the decreasing interval, we still talk about the x value, but which part? That part is matching to the y, which is decreasing. So let's check the graph. So for the graph here, if you pay attention to this one, when we checked from the left to right, from the left side is actually increasing. And then from the, once we pass through the vertex, it's actually going down, so it's decreasing. So for the left side, which is increasing, going up, but for the left side is going down, which is decreasing. So what are the x value matching to this one? If we just check the graph here, from the negative side of the x-axis until -1, this part is actually matching to the increasing part. And if we just pay attention to the other side, and this part from -1 to the positive side of the x-axis is matching to the decreasing. So how do we write down the final answer in the interval? So when we look at the number line here, the negative side we consider is approaching to the negative infinity. The positive side consider is approaching to the positive infinity. So for this part, as you can see, for the negative infinity until -1, this is actually matching to the increasing part. So this answer is negative infinity until -1. This is a part where the y is increasing. And the other side from -1 to the until is approaching to the positive infinity, the positive side of to the -1, which is matching to the y decreasing. So that's how we show the answer. For the domain, if we do not see the breakpoint of the graph, for example, if we see some graph like this, or sometimes we see the graph with open circle, all this one consider the breakpoint of the graph. If you do not see that, that means the domain is all real number. We can write down the answer as using set notation is curly bracket x bar, then all real numbers. That means every single number on the number line, which is on the definition. Or we can just also use interval notation, meaning positive negative infinity to positive infinity, meaning all the numbers on the number line has a definition on the graph. That's a domain. For the range, we just need to check the graph vertically from upside down. So from top part to the bottom. If we really check the graph carefully, y is from the very negative side until reach to the 4. 4 is like stop here, right? So y, there's no number beyond 4 for the y. So what does that mean? That means y cannot go beyond 4. Another word, the maximum value of y is 4. So we can just write down in set notation like we did before, curly bracket y is less than or equal 4. This is one way to do that. We can also use interval notation, which is the negative infinity until 4. So the bracket here is actually meaning 4 is the maximum of the y, so that's why we are going to include the definition for the 4. So you can use either way to represent this. Okay, this is just how we analyze a graph to do this. In the next video, I will demonstrate a quick example to let you practice these terms again, so you can have a better understanding for these terms. Thank you so much for watching and study this topic with me. See you soon, everyone.